My name is Alon Or-bach. I'll do introductions in a moment. This session, entitled One API to Rule Them All, I left off the question mark because it is just a fact. We're going to be exploring both all the opportunities that cross-platform API provides, as well as the challenges. So a very quick word about the Kronos group. Hopefully you guys have been to Chris Rose's session earlier this week, explaining more about what Vulkan is and how we involve in standards. But a very, very brief recap. We're an open consortium of companies. There's over 140 members. Anyone is able to join. There's different rates for smaller companies as well. And what we make, our bread and butter, is royalty-free standards, so that we do not charge royalty for use of our APIs. There's conformance, adoption program, but it's not a royalty-based system. And this is a list of some of the members we have. There's some new ones as well. So what do? We make standards. We have lots of standards. Hopefully some of them you're familiar with. Open GLES, very ubiquitous across mobile, very successful graphics API. Vulkan is now 3 years old. It feels like a lot older. That's what we're here to discuss today. And I'll explain what Vulkan is in a very, very brief single slide. So hopefully you've seen several sessions across the conference explaining in more detail. But Vulkan is a cross-platform API. So there's other explicit graphics APIs that provide a similar interface to modern GPUs. Vulkan's unique selling point is that any platform is able to implement it. And this is a list of the platforms that Vulkan supports. There are some platforms that don't choose to implement Vulkan natively, and what the Kronos group has done with the support of Valve and Mozilla in the industry is create a Vulkan portability initiative, which enables you to use Vulkan through a layer called Molten VK onto those platforms. So, a brief plug. Chris Rose, our developer relations lead, has established a wonderful Slack where you can, if you have any follow-up questions after today, argue with our panelists and engage with Kronos members. I do strongly encourage you to join in. We're generally a friendly bunch. This is you. This was our pre-panel meeting. I do really enjoy being involved in standardization. It is a good gig. And we do also have a very refined way to resolve problems, should they come up, if there's any disagreements.
Knives.
But seriously, there is today's panel. We want to be very open. We want to be positive about what Vulkan has accomplished, but also share with you the challenges of standardizing a GPU API. One thing I wanted to do is just to assess how much we're going to keep things to the panel or interact with you, the attendees today. Can I just see a show of hands of who might have a question that they may throw at us? You don't have to commit. It's not a commitment, just an indication. I won't hold you to it. So, any show of hands. Okay. I'm hoping we'll get more. And just to be clear, there's no such thing as a wrong question. There's just an undefined answer. This is Vulkan. That was an undefined behavior joke. It didn't go down too well. I'm now going to introduce our panel here today. So, Christian Forfang from ARM, firstly, is a performance analysis engineer at ARM. He works on optimizing the Mali series of mobile GPUs, focusing more and more on Vulkan these days in the last couple of years as content has become more available on mobile. Welcome.
Thank you.
Next up is Karlo from Croteam. Karlo has the joy of working on multiple platforms, so both Vulkan and other APIs such as Metal, which he said he would not mention today at all, and no comparisons. We're all friends, but the experience of Serious Engine across multiple APIs with Vulkan is, I think, a key one which we will explore today. And finally, last but not least, Graham Wihlidal from EA's Seed Labs. Graham is a senior rendering engineer at EA and has shipped a large number of titles. I've got a very long list here, including Mass Effect, the Dragon Age trilogies, Star Wars The Old Republic, Battlefield, Star Wars Battlefront, and many others. Graham has been working with Vulkan for a couple of years, targeting desktop and making sure he keeps us on our toes. I'm going to kick off with initial questions to find out more about what you guys do and how you're involved with Vulkan. So Christian, performance analysis engineer, what does that involve, and what have you seen in terms of the comparisons between Vulkan and OpenGLS in your time doing
right.
so?
So obviously my job involves a lot of looking at both games and benchmarks, particularly on mobile and running on our GPUs. So previously that meant mostly glass, like mostly in last 2 years, I would say. First with benchmarks and now more recently also games running with Vulkan on mobile. And in many cases, what games do, they try out a glass renderer and then they're comparing with, or try out a Vulkan renderer and then they compare with their existing glass renderer to see if there are any benefits. So what we've generally seen is there's two parts to the Vulkan story so far. There's the CPU side and there's the GPU side. And I think on the CPU side, it's all being good, basically. Lots of good improvements. The ability now with Vulkan to scale to multiple cores, which is obviously very common on mobile platforms. And across the board, lower driver overhead, ability to do more, even if you're running single-threaded. So that part of the story has been really good. The GPU side is, I think, the more challenging part of it. Definitely, both with early drivers, also early applications still figuring out how to best utilize the API. So I think even now, if you go and look at benchmarks, you will generally see Vulkan is slightly lower. But keep in mind that is for GPU-bound content. And it's something that keeps improving, both on the driver side and on the application side.
Karlo, so the challenge of dealing with so many platforms, if I ask you a question which I hope I know the answer to, would you want even more renderers out in the world, and even more rendering APIs, or do you think that the ability to have a cross-platform API like Vulkan is something beneficial to your life?
Yeah, so we support, I don't even know how many platforms now in our engine. And actually, the way we managed to do that with quite a small team, there are just a few of us in the graphics team, is actually by getting rid of the renderers. So we completely, for example, ditched our DirectX 9 support. We completely ditched OpenGL and ES, like gone, not supported in the engine anymore. And actually that was also a problem for us, especially on mobile, where it was like, no, you should still use OpenGL, but no, it's dead. No, but you should still use it because sometimes it works, but no. So yeah, we are trying to have as few as possible. We do not enjoy making more, so there is a benefit to Vulkan there. Unfortunately, we cannot have it on all platforms, and especially when we did iOS, Molten VK was, let's just say, it's rough. So that was not an option. I don't know what's the state of it these days.
And Graham, I really enjoyed your talk at the start of the tech track here at Reboot. In terms of research, innovation versus standardization, do you see tensions there in terms of speed, agility to develop. Because I was interested that I think you're the first person that lauded the extension mechanism as a great thing, and more about the benefits that you see for innovation with that.
Yeah, I think that's an interesting one. For many years, like, we're obviously primarily using DirectX 12 and DirectX 11 for legacy on PC, and then we have our console APIs for the main consoles. So we basically want parity with DX12 so that we can port our games to Vulkan and sort of see how it is. But we're also sort of doing a lot of forward-looking stuff where there are extensions that the GPU vendors will provide that typically sort of get back-channeled into DirectX without like a really clean way to do it. Can't really name some of them because they're very NDA focused, but from the Vulkan side of things, there's a really nice extension mechanism where we can sort of get access to that stuff really early and with like sort of a maintainable, clean approach. We can sort of just query, does this extension exist on this GPU and driver combination? And then we can activate something like, NVIDIA's shown a lot of stuff recently on the mesh shaders and the ray tracing work. And those are areas that we really do a lot of research into. So Vulkan provides a really nice way to access that stuff, sort of prove out the tech, and then we can go to other APIs, say DirectX, and talk to Microsoft and sort of make our case about why this is important to move the industry forward. If we were to go to Microsoft first, then it has to sort of be pitched as an official API, and there's a lot of complexity behind that. But it's really easy in Vulkan to sort of just make even a one vendor extension to try out some of those features in advance.
So more about the challenge of getting an API right, and kind of the lessons we've learned, and especially the tensions that may exist between different needs for the API, the different markets we're serving. So you're very keen on, very much focused on desktop and on research and pushing the boundary. Do you see tensions in that space?
Sounds like a leading question.
The answer is no.
Definitely are tensions. So with an API like DirectX, it's geared towards like desktop gaming. So there are concepts in there that it's basically very streamlined for that sort of limited set of SKUs and hardware. But when we go to Vulkan, because it covers this vast ecosystem, which includes mobile, even like running on TVs and things like that, the spec can get sometimes a bit overly verbose in areas that make sense if you're working in those spaces, let's say mobile. But if you're taking, let's say, an engine that works on DirectX 12 and you want to run it on Vulkan, you have to sort of navigate those waters to figure out like, what do you actually have to support, what stuff's sort of optional, and what stuff is sort of like spec anomaly to figure out like compatible render targets, like that kind of stuff. What sort of objects you need to create ahead of time versus ones you can just ignore, and the drivers will happily accept that. So there's a bit of tensions where we have to sort of, some stuff's extension based and some stuff is in the core spec, and personally I think that there are hits and misses along that front. Things like render passes and subpasses are very mobile centric. So if you're doing stuff like a desktop only rendering engine, it's just a lot of cruft to sort of navigate through.
How annoying is that in practice, though, to figure out for you?
So DirectX 12 just recently added render pass support, and it's basically just bracketing draw calls together and saying like, what's the metadata for the render target you're drawing to? So here's the resolution, here's the format, and I think that's very reasonable, because if you want any performance even with old APIs, you should still be bracketing your draws together. You shouldn't be going like draw, dispatch, draw, dispatch. That's never a good time.
Yeah, because I kind of figured there are benefits to doing that anyway. So being forced to do it might not be a negative in that sense.
So render passes are fine. I think it gets questionable when it goes into subpass territory, because it's very, I've done experiments on desktop with current hardware, and it's basically noise, ignoring the implementation time. But then you get the added complexity of like, you can't do dispatches between subpasses. So I've done like sort of the canonical test of like a basic bloom filter or cascaded shadow maps, and had no speed up from it. And I was just imagining bringing that throughout an engine like Frostbite and then flipping it on and realizing I just added extra CPU time for no GPU benefit. So that's the kind of worry when it's just desktop hardware, at least as it exists today. But I think going forward, if we start to bring in, say, mobile to our renderers and hardware changes its architecture possibly down the road, then I think that will be needed. But then I'd like to see maybe the spec evolving as well into something that's a bit more flexible and feature-rich versus more the current restrictive one that we have today.
Go ahead.
Yeah, you mentioned CPU overhead as a concern for doing that, but how do you feel about opportunities it opens in terms of being able to port to different platforms? Like we had some talks here yesterday about how easy Vulkan made it to port to, say, the Switch, or pivot from, in that case, mobile to another platform. Is the trade-off just CPU overhead, or I guess also implementation gets trickier on your side, and you might not see the benefit from having that?
Let me jump in. Yeah, so important thing about porting and having stuff like that in the API is that it often doesn't, features of one API don't often fit well with the feature set of the other API. And if you support many platforms with different APIs, then you get into problems. For example, with subpasses, you do not have an equivalent of that in any other API other than Vulkan, even mobile ones. They have like different concepts. And then if you are actually trying to make it like a cross-platform thing, you start running into more problems, because now you need to think like special handling for everything, and it gets messy.
Yeah, and that's kind of the challenge we have in the working group, which is the mission of Vulkan was to have a path that was going to be a fast path that's cross-platform, able to be used on both mobile and desktop hardware. And then beyond that, you can use more of the features if you want to. But I know that kind of the pain of exposing a tiled architecture and getting the benefits there does not necessarily meet how an engine is architected. I'm wondering if we want, I can see someone burning, no? Okay, they saved all the comments before the panel. But exploring a bit more on some of the challenges of extensions, and kind of how to know whether or not they're available. Is that something you think we can improve on?
Oh yeah, I'm answering this one. Okay, so there are extensions. So basically, there are per vendor extensions in Vulkan. Let's say there's like AMD's multi-draw and direct extension and NVIDIA's generated command stream extension, and nothing on other vendors at all. Let's just say desktop. It's not fair to say mobile needs to support that kind of feature. But DirectX 12 for a long time, like since the beginning, has had execute and direct, which is actually a superset of what that functionality in Vulkan supports. NVIDIA's supports more, but you're basically targeting like one vendor, which isn't really scalable outside of research. So there are features that Microsoft has sort of imposed on the vendors, whether they liked it or not, but it's sort of like a come to agreement, do something decent enough, and then we've got this like common abstraction, which is nice because we can target features to that. Say GPU culling or procedural mesh generation, sort of like, there's actually a really good talk by Alex Evans from Media Molecule a couple years ago about the Dreams renderer, and like some of the stuff he showed in there requires that kind of functionality. And Vulkan has it, in this example, they've got that through vendor extensions, but because there's no common abstraction and they're very different APIs, you end up having to have multiple renderers for each vendor. So we're kind of back in the historic days of writing a renderer per driver or GPU. So I think that it can be done better where sort of come to some agreement where you can get sort of this averaging across some extensions and our common abstraction. That would be really nice. Things like, there are crazy features out there, let's say NVIDIA ray tracing, where I'd like to see a generic interface, because while the NVIDIA stuff is awesome, I would obviously want to ship ray tracing features on other vendors. So there will definitely be changes needed for those vendors to support it. So I think it's nice to have these sort of separate extensions per vendor, but there is also a sweet spot of common abstraction as well that's needed.
Well, in my view, the other side of that is what you mentioned before. You have the benefit of getting stuff out potentially faster, but then yeah, you need to like weigh the balance of having multiple implementations and having some stuff that is like completely new and needs prototyping, and we can have faster iteration through the extension system.
So I think one interesting aspect that's come from feedback from developers is what you were touching on, Graham, which is the nature of Vulkan. We basically wanted to avoid imposing software emulations. So avoid forcing GPU vendors that don't support a feature to expose it, even if they don't actually have any hardware backing that. Whereas other APIs just set that bar and it's like, you deal with it. And the question is, should we be a bit more, right, take that hit and we'll relax that philosophy in order to make your life easier for porting and having more ubiquity? Is that a slippery slope that ends up with more and more cruft in the driver, which is exactly what we've been trying to avoid?
So, yes, we have to be kind of careful because all too often I've seen drivers sort of cheat a little bit, where they say they support something and then the implementation is something you would never want to actually go down. Like say you had a multi-draw and direct path and a normal draw path, and some driver says, oh, I support it, but then you query the number of, like the draw count limit, and it's 1. So you go through this path where you're like, oh, I'm going to batch up all my draw calls and I'll
It ticks the box.
multi-draw and direct, and then it basically turns into the most expensive for loop over that extension ever. And it's just, okay, I could have just drawn things. So that's the sort of danger where people can just say, oh yeah, I support this, and because there's a querying mechanism, I'll just send 1 as the limit, and then basically it's just a draw call. That's dangerous because then you'll be falling. You won't be going on the fast path, and typically some of the extensions require a little bit more context coming down from the engine, so it'll be slower than the normal path. So if you're just relying on the query mechanism and somebody's sort of being a bit cheeky with that, then that's a problem. So I think that getting vendors to support more and promote it up to like a common abstraction is really important, but make sure that the ones that actually do that do it properly to some degree of support.
Yeah, it was one recent thing that we found out was the problem with the number of descriptor sets and the way drivers declare what number of maximum descriptor sets they support. And it was very interesting to find, especially on mobile, since the limit set by the standard is 4, there are a lot of them that have it to 4, like on desktop, like 256 or something, I don't know. But at that size, you don't care anymore. But yeah, 4 is like a very small number if you want to have different sets for different things and want like mix and match. So, but yeah, because the standard says 4, we'll just do 4. And yeah, one of the things that was mentioned is, oh, even though the driver says 4, you can maybe try and use more. Like, what?
No, that's not valid.
For us, this is one example of where our hardware actually supports 1. We don't have the concept of descriptor sets in hardware, so we end up having to do the emulation to support this. So it is one example of where the spec has tried to sort of set a higher limit to make it more accessible to use, and to set the path for future hardware to support more, which we are doing. So by applications using a higher number now, that should improve in future hardware for us. Also, even though there is emulation involved, I think that for us the cost is very low in practice, so it's not actually a problem, but it certainly depends on the particular feature, like where you do something like that of having emulation in the driver. But we try to generally avoid it as much as possible. I think that's the one big case where we actually do it.
And I just realized I hadn't properly introduced myself. So from Samsung Electronics myself, I work in our game dev team, but what I do is I try and bridge all the joy I have with game developers and try and push that into where the standards go. And we work with a couple of GPU vendors in particular, ARM and Qualcomm, and so try and push the requests onto Christian and the lovely folk at ARM. So that's a clear request for, we need 5. Is it 5 we need, or
No,
6? That's an official request now.
At least 16.
Noted.
Start from that.
I think that in the Vulkan working group, the discussion we have and the dynamics is there's a push for, we want something, we want a feature, we want to raise the bar, and vendors will say, because you have very direct competitors in the room together that will not share all the information with each other, but it's sharing enough information to say, look, if you force this into the API, this will give us a performance hit. We will not be able to do this well. And there's a kind of quid pro quo that I won't screw you over because then you might screw me over later. So we try and not put something into the standard that is going to be a bad penalty. But that is the challenge of how do we get it and when do we get it wrong because it's just not usable. So can I just see, there was a couple of indications of questions. I will get a bit of interaction. And do we have the roving mic? The microphone? Were you after asking? Yeah, of course. And any indication of others that want to jump in? Oh, encourage me. Oh dear.
It has begun.
Go ahead and please introduce yourself. Oh, good.
Do you want to be in the spotlight?
One thing I wanted to ask actually for you, you mentioned using a lot of extensions because you're doing quite advanced stuff that is not necessarily standardized yet. For Croteam in the Series engine, do you use a lot of extensions on your side, or are you quite for the standard part of the API you are using? Do you feel that is performance portable across the APIs you're using, and so that would sort of indicate that how it's implemented is actually something all the vendors can support?
Well, for us, we use extensions when we get a noticeable performance improvement. Of course, then it's silly not to use them, and if it's not too burdensome. But we also like to have fun with the extensions that are feature.
When
extensions,
available,
yeah. For example, with the work that Alon talked about with Google display timing and things like that that are not available on any other API.
When you use the standard API, do you feel the need to have vendor-specific paths in the backend of the driver, or are you generally able to use the same API calls on all platforms?
Well, you never feel the need to use I would really want to use something vendor-specific
because I ask, because the dangers of having an explicit API is that you might have the need to do different things on the different platforms you're running on. I think if you don't need to do that, that is a success point of the API that you don't need to look at and branch on, am I running on this GPU or this GPU?
Yeah, but there are so many combinations there. So in an API like Vulkan, I can't really see it ever working without any vendor-specific parts, because each vendor likes to compete on features, and that means that there are going to be specifics that they are better at. And APIs, especially with the ones that have to be standardized as much as Vulkan, will never be able to cover everything.
And I think just the way I've seen our dev techs approach it is often when you first port to Vulkan, you just want to get it working, sort out synchronization so you just don't have artifacts all over your screen. then maybe you start using the more interesting bits of the API and start exploring and optimizing for different renderers. Just a plug for one of the things that we are working on is trying to pull together the best practices for different vendors in a more coherent place, so you don't have to look at 8, 9 different PDFs and search for bits and see is this still relevant or not, and just have them more accessible, even if they are competing bits of guidance. Graham?
Yeah, so speaking about the combinations, one thing I'd really like to see in Vulkan is more of like a flat API where it's not hidden under abstractions. There's basically everything is very explicit extensions, and that includes mobile. So say there would be like a subpass extension that you could opt in for, but then having layers on top of that are open source, where basically is just providing some sort of combination and abstraction over certain extensions. Like say this is the desktop gaming one that I know every time I mention it you want to strangle me, but like it's equivalent to like DX12 tiers, where you could say, let's say AMD, Intel, and NVIDIA are all in on like these layers. And so instead of trying to play the combination guess game of like, I hope this works on all 3 of them on desktop, if you're doing a PC game, it'd be nice if there's sort of this layer works. Rather than trying to force that in as like the opaque API, and then mobile either would win or lose depending on what the feature set is, because developers would target it, try and port to mobile or desktop, and have to do sort of specific paths. It would just sort of clean some things up, I think, both in the API and also in the sort of the understanding about how to get performance out of the API with certain combinations of features.
So you would see that the specification that is standard across platforms is has more that's kind of per platform within it, or does that show everything and then you build the per platform layer or utility above that?
I would say it shows everything, because there's various use cases, obviously. So from what we're currently doing at Seed, we just target like the highest end GPUs, whatever the latest extensions are for, say, NVIDIA or AMD or Intel. Mobile is very important to EA, but like for my group, we're just doing more desktop stuff. So if we had a high-end desktop layer that doesn't show any mobile stuff, but underneath it, like Vulkan itself has all those extensions very explicit, that's one use case. Another one would be like possibly with Croteam, where you would have mobile and desktop under some more unified API, where you could be implementing it once and hopefully having it be decent enough on both, and then maybe having a little bit of explicit paths in there. That could possibly be nice.
Yeah, but even for us, it wouldn't have been such of an issue to have, I mean, not to say 2 Vulkans, but to have one path that is more optimized for desktop, and then another one in a different way of doing things that is more optimized for mobile.
I think what you are basically arguing for is more things to be optional. TLDR, that's what you're after, so you don't have to do it if it's not necessary.
Yeah, so one example is when you're creating a PSO, like a pipeline state object for DX12, things like depth bias are in the struct, and it just causes like unnecessary permutations, because on desktop hardware that does nothing to what it's actually doing under the hood. And I think Vulkan did this part really, really well, which is the dynamic state, where you can basically opt in, or opt out, I should say, of things that are normally in the PSO struct. And depth bias is one of them. So I like that Vulkan has this list where you can just sort of request as much as you want, like, to be removed from the struct, and then if the driver allows it, then you can do that. Versus it sort of being this very opinionated API where, like I remember in the early DX12 days, I was pushing to get stencil ref moved out, and Microsoft thankfully did that, but depth bias stays behind, and we're just kind of really annoyed that we have to create PSOs for, basically we have to take our PSOs and multiply them by, let's say, 12 if we have a bunch of depth biases for shadows and particles and terrain and other things. And it really irritates me because I know that there's nothing under the hood that needs this information. Similarly, Vulkan has this with the render passes, where you basically have to have, you should only need the metadata for render pass, and DX12 proves this because its spec is just the metadata, but it ties the memory allocation in Vulkan to that. Those are cases where we should be able to opt out or opt in of that sort of opinionated decision.
So we're going to get the render pass rant out of the way first. Now that we're on it already, would you like to chip in once we? And where's the button to kill the mic?
Okay.
That was a joke.
So, about the render passes.
You introduce yourself.
I'm Dean from Croteam, and I hate render passes. And now you say hello, Dean. Yeah, no. Thank you, thank you. No, on a more serious note, this is not render passes. I have a question for Graham about extension system. When you have a new extension pushed from one vendor, and then you got, I'm talking about desktop, and then you got it for a second vendor, and there is also a third vendor that doesn't support that extension for some reason. How do you feel about it? How do you progress from that? You have NVIDIA, AMD, and Intel, and one of those vendors, I mean, it's sort of it's similar to the desktop system, to the mobile system. You have also free renders. So I'm just curious, how do you find this situation? You know?
I think it depends on what the extension does and sort of the hardware implications there are for the vendor. So if it's something complex like ray tracing, for example, that's going to be quite a lengthy discussion because it's not just like, oh yeah, that's a cool idea. I'll add that. I'll add ray tracing. Why not? It'll run the same speed as this custom
Toggle
thing
it
you-
on, yeah.
Yeah, exactly. So in that case, it's a very complicated discussion with the vendors and quite ongoing when those cases come up. When it's something fairly trivial, like the descriptor set count is a good example. Another one is when we started doing Vulkan a couple years ago, viewport transform, like, come on, where everything's flipped upside down. It's like, oh, we have DirectX as standard, we have OpenGLs, let's do something in the middle and just completely ruin everything. So in that case, the advice was like, oh, just flip your Y coordinate in your vertex shader. And we're like, oh yeah, like all 60 or 70,000 of them. Yeah, maybe that works for like a spinning triangle demo, but not for an engine. So, plus I refuse to add a single instruction for something that is not my fault.
But I think just to be fair, we did listen to that very direct feedback and act on it.
Yeah, so that was what I was getting at, is that in the very beginning, AMD had like the specific extension for negative viewport height, and we used that, and we basically just like at gunpoint threatened all the other IHVs, basically saying like, I mean, they were very nice about it, but it was basically one of those, something that we know is going to be trivial, but is super important to us, and maybe people not in our shoes, they might not see how important it is, but we just sort of really put out the urgency for that extension, and the other vendors picked it up, went into core Vulkan, and that's been really nice. So if it's simple enough, then we just kind of push it out there and get the other vendors to adopt it easily. But when it's the more complex ones, same sort of pattern, but it's an ongoing thing, just to sort of work out what the hardware differences might be, because some of them are quite complex.
Okay, the question here, front.
Test. Oh, now you can hear me. So, quick introduction. I'm Dietmar, and I'm a now freelance programmer. But where I'm coming from is that I had the joy of porting our in-house engine from the console world to the mobile world in the days before Vulkan.
Oh.
Yeah, and one of the most frustrating factors there was that the mobile APIs only provided a very basically OpenGL ES, which is did not map onto the actual hardware very well, so you had to do arcane things to get things happening under the hood. So I'm very happy that Vulkan now seems to be standardizing on all these things. And that's why I'm also on the side, which having the API spec go across all the platforms, because it rids us of the illusion that we want to find ourselves under, that mobile is a fad and will go away.
See, Graham?
It's growing much faster than desktop, and we won't get rid of it anytime soon. Which I entertain the illusion as well that it's just something different there, and we don't need to think about it. But the reality is that it will become more and more important. And the second thing is I don't see it necessarily as it pulling desktop down, but lifting mobile up.
So, question: which API were you using on desktop at that time?
We had and at the time when we added mobile, we went from DX9 to DX11, and from mobile from nothing to OpenGL ES2, I think.
Yeah, I think thank you for the question. Feel free to jump in again.
Yep.
The challenge of producing a new API. This is the first time I've been involved in one. I am really positive about the direction Vulkan is going in, and we are really learning from the feedback we're getting. One of the big missions, as well as being very explicit, close to the metal, was to avoid the unnecessary pain that existed between OpenGLES and OpenGL, where because they forked, and then and that's kind of where I see the danger of the direction you're pushing in. If you allow things too much freedom to just go off in different directions, and you don't try and bring them together, then you end up with really strange, unnecessary differences that as you're trying to port between between desktop to mobile, it's like, why is this different? And it's often just, because a year or 2 years or 3 years or 20 years ago, someone said something in a meeting, and ever since then it's forked. And that's what we're trying to avoid by having Vulkan as a cross-platform standard.
I think one aspect of that as well is having a single community around the API, and that improves things like tooling as well. I think RenderDoc is one example of a tool that works on equally well on both desktop and mobile, and has had contributors from both spaces. Also tools like shader toolchain, Spear v Cross, for example, is something ARM has contributed to, which has helped the ecosystem around Vulkan a lot. And you wouldn't necessarily have that if you split the API in two, so you had some Vulkan ES kind of thing, for example.
Yeah, but to be clear, I'm not wanting to split the API. That's why I wanted sort of like the flat one API with everything exposed, and then sort of convenience layers on top that are open source, so you can actually see what they're doing.
Personally, I think that sounds like an interesting idea, and it's something to explore for sure.
Yeah, definitely. Even though I troll Alon all the time about Vulkan ES, just like kick all the mobile stuff out. Let's start up Vulkan ES. That would be bad for sure. But I do think there is room for improvement with the current approach, and I think that maybe that horizontal approach with layers would be possibly a solution to that.
I think one of the inherent tensions that does exist is the speed and where the different GPUs are at. That you do have features that can span across, and that's where we definitely try and let's bring everyone on board and make sure that this is implementable on all hardwares right now. Then you've got ones where there is a big gulf in power 3 watts to 300 or whatever the latest Turing uses. That was a joke. It's 3,000, I think. The question is kind of when do you know when to say we're cemented? This is ready, and this will be available everywhere. When one market is naturally years behind having it available. So kind of the work that you do and is done at ARM in terms of the research, even though mobile hardware is not ready for features. And do you find that tension? Because you don't want an API to be cemented in desktop, and then you have to implement it N years down the road, and it's the wrong API.
I think for us, we generally feel Vulkan is a good abstraction for our GPUs, and so that's why I ask questions about how sort of it's working for you if you do need separate paths for different hardware and things like this, or if you feel the need that the standard API, the stock API, is actually enough to do what you want, even though you might want to go to extensions to squeeze out sort of the last bit of performance of the hardware.
To like broaden this discussion a little bit with something potentially a bit controversial. In my opinion, even with the render passes, sub passes, and everything, our main obstruction on mobile wasn't that much the API itself. It was the implementation. So various issues with the drivers, and things like that. That's where the crux of the problem was for us. So like impossibility to test all the millions of combinations, I don't know how many, of various devices, drivers, and the entire driver updating problem, let's call it that, on Android. So things like that are by far the biggest issue.
Yeah, and that's definitely a problem for us too. Like the driver release cycle on Android is a problem. The thing to keep in mind is Vulkan is, what is it, 3 years, not soon to be 4 years. For us, that means not that much more than 3 driver releases. And you consider the first drivers coming out, we simply did not have a lot of content to test with. And the quality has improved. And I think even like at this point is where we can seriously talk about the driver quality being where we can seriously ship games on mobile. It's taken this long. And I think that's the problem you would have with any new API you're shipping on that kind of platform where you're not able to ship drivers frequently. And I know Google and OEMs are working on improving that situation. And this is something that's really annoying for us as driver vendors, to not have the ability to ship updates and fixes for games. And that's definitely had an impact on the adoption rate.
So what you're saying is you're happy to provide updates for us for any branch of the driver code we fancy. Is that?
Sure.
Well, I think that it is a real challenge. It's changing the way the mobile market works, and there's many players involved there. And we've had several attempts at this, and there's going to be more attempts yet to make it something that is more easily deliverable. But in mobile, unlike desktop, you've got the operators, the carriers involved, and the QA bars they set for any software updates. Plus the fact that, don't forget, it's still a mobile phone. And there's the main business model is still being a phone and making sure that all the phone functionality works. So I think there's definitely, the more pressure we get for game developers to try and change that, I think the better, so we can deliver more updates and make it easier to put fixes through. But I think just one comment. I'm not trying to kill that conversation, but maybe I am. The power of the chair, Karlo, because you mentioned about OpenGL being dead, and I think that's kind of, from your perspective, that perhaps is true. But on mobile, content, OpenGLES is still the prevalent API for what most game titles are shipping in. And only this year, with Unity being the most popular engine on mobile, are we seeing Vulkan becoming the default renderer in 2019.1 instead of GLES. So I think it's definitely shifting, but it is far from dead in the work we have to do.
It should be dead.
Yes, as far as we are concerned, it's dead. Completely, like, gone. Yeah, I mean, it's like we were discussing earlier with renter passes and everything. That's the case where Vulkan fits very well for the renders that are on mobile. But OpenGL, yes, it's a completely wrong abstraction for everything that is actually going on under the hood. So there should be no reason to use it these days.
But being diplomatic, I think the issue is, we are very, very supportive of Vulkan in Samsung, as are Google. We are trying to push the boundary of what mobile games can do, and Vulkan is the correct API to do that, so you don't have drive overhead, so you can actually exercise the GPU correctly. But if you're not CPU bound, if you don't have that much draw call overhead because you're a 2D nice cartoony game, there's no, the need to move to Vulkan isn't quite as strong. You still can get benefits in terms of reduced power consumption, longer battery life, but there isn't that quite the same imperative as all those amazing high-def grass blades that you have in Series Engine. So I think that's kind of where I'm defending both will live for a while to come.
I gave my mic up too early there. So I think the example that for the 2D games, OpenGL ES is still a valuable abstraction is very wrong. Because I made a 2D game with OpenGL ES with pre-rendered sprites running around on the screen. And had we had, and I even don't know if Vulkan provides it, back in the day, PowerVR was the predominant GPU on mobile, so all iOS devices and many Android devices. And had we had explicit access to this tiled rendering thing and could have sorted our scene in a way that we can have actual benefit from the tiled rendering, because we didn't, because everything has transparency, so the whole thing fell away. We could have had much better performance on that.
Yeah, that's one thing I do like with Vulkan, is that it makes it much easier to use some of these features we have in our GPU. That is sometimes something you can access in OpenGL, but you would have to go to extensions, and that always brings some pains.
Yeah, OpenGL is a very esoteric process. You have to do things to trigger the driver to do the things you want, and it's extremely frustrating because not every vendor will support the same trick. So if there's an explicit and API, especially one that does not have the emulation that was talked about there, so if you can't do something, it just should tell you I can't do that, and you have to find another way around. So I'm on board with you there. But if it gives, with the extensions, it can give you access to the things that actually on mobile GPUs than on desktop GPUs. I think PowerVR, I'm not sure about the Mali, also you can read out the pixel you're rendering to for free, because it's already in this little tiled buffer, which I think is not the case on desktop GPUs at the moment.
No, this is a unique feature on mobile.
Yeah.
And why we have subpassers. So in order to make use of that architecture.
Yeah. And also,
Compute
I think also this might possibly return to consoles, if you think of Switch and all other low-power consoles, that they use the same tiled rendering approach that Xbox 360 already had. I think it's possible that might make a return, so it's nice that the API has provisions for that and not pretend it doesn't exist and do some crazy emulation that you then have to as backwardsly work around with. Again, not really a question, comment.
Thank you. Can I see any other questions or comments? Indication? Up here in the front.
Hello, my name is Chris. I'm software engineer at ARM, and I have a question regarding secondary command buffers. So what we spoke about subpasses and underpasses. So we know Vulkan was designed to be multi-core architecture and be scalable. We've seen examples in presentations as well, primary command buffers used in multiple threads, but not much about secondary command buffers. So what do you think? Was this a good choice for Vulkan, or there are any pain points for developers why they're not adopting or talking about this?
Yeah, I mean, that one I think could fall under the whole like porting legacy code over and just not taking advantage of features. Whether or not they're a mistake or not, I think there's just data missing from that possibly. Like, just like with subpasses, I don't think there are really good case studies out there of an engine that actually properly supports like a feature on or off. You know, there'll be lots of stuff like, oh, this game uses subpasses, therefore they're fast. It's like, sure, but what is it without them? I could see the same thing with secondary command buffers with like inheriting render state, that kind of stuff. I think just people not using it is just like subpasses, just legacy tech that they're just trying to move over. They probably had maybe a concept of like multiple command lists they would do in parallel, but then there wasn't really some sort of hierarchy to the command buffers, so that might be why they're not being used. So that's probably what my guess would be about why they're not used very heavily.
Yeah, I think the problem of having legacy tech that you're porting over has been a problem generally. And it's something we see specifically for render passes, where on mobile it's particularly important to pick the right load operations, the right store operations to avoid extra bandwidth. And it is a real cost. And it's something when I look at Glass and Vulkan comparisons for games, that's often what comes up, and it is what's costing engines performance. And one advantage of GL is that you have a driver that's now many years old and has optimizations built in that will detect these kinds of common cases where it's hard to get it right sometimes, or where when we ask the drivers or the applications to be explicit about something, they might not have the information to do the right thing. And in OpenGL, we had the ability to override that and correct it on the driver side. This is much harder to do, or impossible to do in Vulkan. So there is much more reliance on the application as sort of what was requested from an explicit API. But it brings a lot of challenges on the developer side.
Yeah, I have an example of that is like I did a rough, like unofficial prototype of just like, oh, let's see how hard it would be to port Frostbite to Vulkan. And try to do it using the existing architecture, and because there was no concept of subpasses, there was some concepts in there with high-level engine knowledge where I could sort of roughly get that in the right ballpark, but I had to basically record to my own high-level IL and then go back and group draws into subpasses, and just the cost of that was not worth it, obviously. I mean, I got it fast enough, but I would never want to ship a game where it would be compared against, say, like DX12, where we had built the architecture for that particular API. And then when we went to do our R&D engine, Halcyon, we at least had this knowledge of how Vulkan wanted things like render passes to be implemented. So then it became like an actual high-level concept, and then it was trivial and clean. Like I basically didn't have any concept of immediate clears in our high-level IL. I basically just only did it with render pass load and store ops. So that was really nice, but then we don't have the subpass concept because that would be a lot of just extra overhead when we're not even targeting mobile currently. So finding the right balance is important, I think.
Yeah, I think that transition is still going on, especially with the major engines today.
So I feel very bad because I was enjoying things so much, realized we're overrunning. I've got a question from my manager over there.
This is beginning to look a little staged, Alon. I'm just wondering for each of you, in about one sentence, what's the single best feature and the single worst feature, and which of those wins of Vulkan?
Single best feature is render passes. And the ability for applications to specify upfront how to manage tile memory, because this is a real hardware feature on
single best and single worst, about a sentence each, and which one wins. So single worst?
Synchronization. That's hard for developers to get right.
Okay, and which wins?
Render passes.
Okay.
Controversial one.
Single best feature, definitely portability. So making the port for Nintendo Switch, for example, is very, very easy to do if you already support Vulkan. So it's a huge win. And worst is, well, yeah, sub passes, render passes, all of that. But portability definitely wins.
Okay. Graham?
Oh, it's a tough one. So I think best feature, with the caveats I mentioned earlier, is the extension mechanism. Again, don't make a billion extensions, please. But worst, okay, I can't do two, can I?
No.
You can see the extension mechanism as well.
Oh, yeah. Well, this is sort of cheating, but since you mentioned render passes, see what I did there? Synchronization, I would say. There are so many nonsensical combinations because of all the hardware that gets supported, but also sort of just ambiguity in the spec. And I remember when we started with Vulkan, I was talking to Tobias Hector about it, and he was telling me, oh, I know, it's great, it works perfectly. And then over time, I started showing him examples, and then he started to dig into it himself, and he realized, oh my God, how are you guys using this thing? So that's why he sort of did that simple Vulkan synchronization library on top of that to make it a lot more sane. And it basically just remaps from like a higher level concept down to the Vulkan implementation. And it gets you about 99% of the way there. And the last little bit, it's kind of like, how much pain do you want to endure? So I think that synchronization could definitely be improved a lot. I think that's the part where the explicit APIs, including DirectX, have kind of This isn't one sentence, I'm sorry.
Yeah.
It's a bit of a rant.
And for my best feature, just to annoy Graham, and because I was involved in it, swap chain, which is definitely just one word.
2 words.
One word. And worst feature is synchronization, just because it is so painful. One final last question. On a scale of somewhat to overwhelmingly, how awesome is Vulkan? Okay, a good answer. So now that we are overrunning, we are overrunning into the next session, which you should definitely stay for and not leave the room. And then there's going to be another final session from another member from Imagination today. Please do come to it. And as I mentioned, please come along, join the Kronos Slack for more fun discussions like this. Thank you everyone for coming. And one last point, like many of the companies here, we are also hiring. We need more people to make Vulkan better. Please come join us. Thank you everyone.